another example on this. So show that sine of 2a over 1 plus cos of 2a equals tan of a. So all you're going to do is you're going to go to your log tables, have a little look for sine of 2a. So sine of 2a is 2 sine a cos a. So let's replace this on the left. 2 sine a cos a. And on the bottom, you're going to replace cos of 2a, which is cos squared a minus sine squared a. Okay, now we also had another formula for what cos of 2a is. So remember, we could write cos of 2a with sines in it or with causes in it. Okay, do you know what? We'll leave it for a second. Let's just write cos of 2a is cos squared a minus sine squared a. Okay, for a minute that's what we'll do. All we've done is replaced on the top and on the bottom sine of 2a and cos of 2a. Now I want it to be tan of a. Can you remember what tan of a is? If you go back and have a look, tan is sine over cos. Alright, so really I want just to be left with a sine on top and just to be left with a cos on the bottom. So realistically, to be left with a sine on top, I'd need that cos a to cancel with a cos a somewhere on the bottom. Okay, and also I don't need any sine squared a's on the bottom. That's not going to help me. So if we go here to this formula here, I've got cos squared a, just get rid of that for a second. I have cos squared a plus sine squared a is 1. So cos squared a is 1 minus sine squared a. Well, I have a 1 and I have a minus sine squared a. So 1 minus sine squared a is actually cos squared a. So on the bottom, what I'm left with is cos squared a plus cos squared a. Because 1 minus sine squared a is cos squared a. Okay, so I end up with 2 sine a cos a over cos squared a plus cos squared a is 2 cos squared a. Now remember, cos squared a is the same as cos a to b squared. So the 2's are going to cancel. And the cos squared a and the cos a on top is going to cancel. Just keep going underneath ye. Okay, we're leaving that as tan a the whole way down. So here I have sine a cos a over cos a to b squared. You don't need this in your proof, but it's just for yourself. You can see where it came from. So that cos a and that square cancel. So I'm left with sine a over cos a, which is tan a. And that's what they wanted me to prove. Any issues with that?
Is that a mandatory proof?
No, not at all, no. I think for the rest of this chapter we're finished with those mandatory proofs.
Miss, you know the way there's so many different ways to get the cos 2a, like how would you know which one is like more suitable for the question?
Yeah, so it is hard to decide. I think by looking at the right hand side and seeing what do they want me to be left with, sometimes that kind of gives you hints on what you should do. Okay, so like what I said there is I know tan is sine over cos, so I need a sine on the top and just cos on the bottom. So having sine squared a is not going to help me there. Okay, so that's how, but, and like it may be the case, and it probably will be the case in the Leaving Cert, you actually try it a few ways. So you say, okay, I'm going to replace the sine squared a with something, or I'm going to try something else. Okay, so it isn't like you might have a different formula for what cos of 2a is, and then you'll continue down and you might get stuck and you'll try something again. It is a little bit of trial and error in these.
Yeah.
Okay. We do another one, part 2 of that. Can I get rid of the board?
Yeah.
Okay. So, Show that cos theta to the power 4 minus sine theta to the power 4 is cos of 2 theta. Now, looking at this, I've got a minus in the middle, and I've got to the power 4 and to the power 4. Can anyone give me an idea what it might be? What you might try? What if it was this? What would you do?
Difference of two squares.
Yeah, exactly, you would. Okay, it is actually difference of two squares. So that's x squared minus y squared, x squared plus y squared. That's what you would do in this scenario, okay? So it's cos squared theta to be squared, cos squared theta to be squared minus sine squared theta to be squared. So that I'm here. So when I put it in, it's going to be cos squared theta minus sine squared theta and cos squared theta plus sine squared theta. Now you know cos squared theta plus sine squared theta is 1. So you get cos squared theta minus sine squared theta by 1. And also you know, just going here to your log tables, cos squared theta minus sine squared theta is actually cos of 2 theta, just down here. Okay, so cos squared theta minus sine squared theta is actually cos of 2 theta by 1, which is just cos of 2 theta, which is what they asked you to show. Okay.
Miss, how did one of the brackets like go down to 1?
Because your identity that we proved at the very, very beginning here, cos squared a plus sine squared a is 1.
Okay.
So that there, cos squared theta plus sine squared theta is 1. So write that little note to yourself if you want. That's page 13 in your log tables. So an awful lot of these questions is literally going to my log tables, having a look at all my little identities and seeing, okay, what have I got here? Okay. Now, just another little subheading. Any other questions on that?
No.
Okay. Alright, so we're still in double and half angles, okay? So expressing in terms of tan A, you also have these 3 formulae. So these are the ones we've been using. You also have these 3, tan of 2A, cos of 2A and sine of 2A. We've looked at tan of 2A already and where it came from. Cos of 2A and sine of 2A. It's just the same formulas up here, but you've rearranged them so that you have them in terms of tan. You do not have to prove how you got them, okay? So we just have to use them. So all we're going to do is we're going to write out sine of 2A, and this is given to you, and cos of 2A. Okay, and sometimes it's helpful to use these formulas in a question. So for example, I'll just call it example 1 here. If sine of 2a is 3 over 5, find two values of tan a. So sine of 2a, if I go with what I did the last day, sine of 2a, I can only use 2 sine a cos a. So that's not actually going to help me because the question is asking for tan. So I'm given sine of 2a and I want tan. So you're going to replace sine of 2a with your formula that includes tan in it because we've got tan in the question. Okay, so this is my formula for sine of 2a. So let's just replace that. And that's equal to 3 over 5. Okay, all you're going to do now is you're going to cross multiply. So 10 tan a equals just tidy up a little bit. What is that? Yeah, it is. It's a quadratic, okay? So it's a quadratic with tens in it. Now, I personally don't like dealing with that, so I'm going to say let y equal tan of a. So I'll have 3y squared minus 10y plus 3. Okay? The tan a, I'm just changing it to y. And from here, you're going to do factorizing, or minus b. And so you've got your 9, 10 plus, so I get y is 3 and y is a third. Okay, now find two values of tan of a. Well, tan of a is 3 or tan of a is a third. They didn't ask me for what a was, they just wanted what tan of a was. Does that make sense?
Yeah.
Yeah, thank you. Okay, and one final little note on this. Can I get rid of the board? Just something to be mindful of. Sine of 2a is 2 sine a cos a. Sine of 4a would be 2 sine 2a cos 2a. Sine of 6a would be 2 sine 3a cos 3a. Okay, so you're just using what you know and kind of expanding on it a little bit. If sine of 2a is 2 sine a, then sine of a is 2 sine a over 2. Okay? When it's 2a, you halved the angle. When it was 4a, I halved the angle. When it's a, I halved the angle. Okay? Yeah, and just same, I suppose, if we're talking about cos of 2a, we know is 2 cos squared a minus 1. So if I wanted cos of 4a, what would it be? Similar principle to up here. So in all of these, my 2 didn't actually change, but it's the angle that changes, yeah. So this is 4a, this is the double, so this is the half. 2a minus 1. Okay, and same, this is the double, so this is the half. 2 cos squared a over 2 minus 1.